Hey guys, Mr. Backward here. In this video, we're going to look at the derivative of e to the x. So we're going to look at exploring the derivative of e to the x, and we're going to do it using our original definition of the derivative, which is the limit of f of x plus h minus f of x all over h as h is approaching 0. So as we're looking at this e to the x function, then we're doing the limit as h approaches 0 of e to the x plus h minus e to the x all over h. Now we're going to work on simplifying some things down within that fraction to make doing this limit a little bit easier. The first thing I'm looking at is that e to the x plus h. Now we do have to remember some properties of exponents. And properties of exponents, when you've got powers being added together, what that really comes from is having the same base being multiplied together with some powers. So if we had a squared times a cubed, we would add those powers together to get a to the fifth. So what I'm going to do with this addition in here, this e to the x plus h, I'm going to separate that out into two different pieces being multiplied together. So I'm going to separate this into e to the x times e to the h, and then minus e to the x all over h. And we're still doing that limit as h is approaching 0. Now what I'm going to be able to do on top is both of my terms have e to the x in it. So I'm going to factor e to the x out of there. So this is going to say e to the x times e to the h minus 1 all over h. And again, we're still doing that limit as h is approaching 0. Now, as we're looking at evaluating this limit as h is approaching 0, this first piece, this e to the x, doesn't have any h's in it at all. So I'm actually allowed to remove that from the limit, and I'm going to put it out in front. So this is going to say e to the x times the limit as h is approaching 0 of e to the h minus 1 all over h. Now, this limit is going to be tough for us to do algebraically, so we're actually going to look at this chunk graphically. So I'm going to type in this e to the h minus 1 over h into my calculator, and I'm going to look at what the graph is doing as we approach that h value of 0. So in my calculator, I've got that function typed in. I have to use x's in here because my calculator doesn't use h's, so it's e to the x minus 1 over x. If we graph this out, we're looking at what's happening as we approach 0. So we're approaching from the left side and from the right side. So if I trace this on the left-hand side as I get closer and closer to that x value of 0, I can see that my y values are getting closer to 1. At 0, it doesn't actually exist because we would have 0 on the bottom of that fraction. But then if I also approach from the right-hand side, I can see that those y values are also approaching 1 as we get closer and closer to that x value of 0. So I know that this whole limit on the end here, we just looked at it graphically, and we just said that that limit was going to be 1. So this is really going to say e to the x times 1, but e to the x times 1 is just e to the x. So what this means is if you're dealing with a function y equals e to the x, and you find its derivative, the derivative is the exact same thing. It's still e to the x. Now, just like we've talked about before with some of our other functions, if that x variable, if that's actually a differentiable function, so if you've got like y equals e to the u, where u is some differentiable function, then as you're finding this derivative in here, this is going to be e to the u, but then because of the chain rule, because of this kind of inner function in here, you would have to attach whatever the derivative of that du function is. So in this example, we've got the equation y equals e raised to the x plus x squared power. So we're going to find its derivative in here. So the derivative of this function We're going to have to use the chain rule because I see that the power is a differentiable function. So this is going to be e raised to that exact same power, but then we have to multiply by the derivative of that inner function. So if we differentiate that x, that just turns into 1, but then if we differentiate that x squared based on the power rule, that turns into 2x. There's not much simplifying that we can do with this, so I'm just going to leave that as my final answer. That's going to be it for this video. Thanks for watching.